Okay, so before we get started reviewing the equations calculations you've been doing, just something to make you clear about when you're using this video. Uh, so just going through this and copying out the correct answers is not going to be helpful to you when you use this video. The idea for this video is to help you through the stages of logic that you have to use when you're handling equation. So when you're working through this, this is the key. Make sure you understand why each step has been done. And if you don't understand, that's the time to ask someone else who in the class who maybe can help explain it to you. Because that's the important part in physics. You understand why each step is being done. Because in physics, there is a logical reason for absolutely everything. So it's not about random guesswork. There is a logical reason for everything. And we'll see what that is as we go through. So before we get started on the specific questions, these are the 5 equations you're going to have to use as you work your way through. So as you're reading the questions, bear in mind these are the equations you have available to you. And obviously the further through physics get, the more equations you will have to draw on. But these are the 5 that we're starting with for now. So let's get started. So if an object has a weight force of 28 newtons when its mass is 0.7 kilograms, what is its gravitational field strength on the planet? So the thing I'm doing when I'm looking at this is picking out the things that I've been given. So you can see here we've got weight force. So this, when we use it in terms of symbols, the thing that we're looking for is a W. We've got its mass, and we're looking for its gravitational field strength, G. So what we need to do is go to our equation sheet, look for an equation linking those 3 things. Here are our equations, and right bang at the top of the list, here we go, we've got an equation that relates W, M, and G. And it tells us to calculate W, we need to multiply M and G. Great. State our equation to start off with, because remember, we're always stating our equation and then working from there. So what I'm looking at this, I'm going, okay, so we want to calculate gravitational field strength. That's what we're working towards. Currently, gravitational field strength is being multiplied by mass. So I'm going to divide both sides by mass. That gets G by itself. And once we've done that, you can see, there we go. We've made G by itself. Now what we can do is we can plug in our numbers. So we've got a weight force of 28. So in place of W, we put 28. Got mass 0.7, so we put 0.7 into place of mass. Calculate our answer, and we get our unit. Now, how did I know what the unit was? Well, the first thing is you can see it if you look it in the equation table. That's the first way. The other thing we can do is we've done force, weight force, which is in newtons, divided by mass, which is in kilograms. Therefore, we get newtons per kilogram. Okay. So that's our G. So next question, object has a weight force of 25 newtons on a planet with gravitational field strength of 15 newtons per kilogram. What is its mass? So again, same process, looking what have I been given in the question? I've got weight, I've got G, and we want to know its mass. So we've got the same 3. I'm going to pick exactly the same equation because that's what relates those 3 things. What we do is we state our equation. This time we want to calculate the mass. So I'm going to make mass the subject. It's currently being multiplied by G. So we do the opposite. We divide by G. And we get this expression here. Now what we can do is we can substitute in our numbers. So we can see weight force is 25. G is 15. So we can plug those in. We can simplify it. So 25 and 15 are both multiples of 5. So I've cancelled 5 top and bottom. We never express our answers as fractions in physics, always as decimal. We're not going to write out a whole calculator. We're just going to round that to a sensible number of specific figures. So I'm going to round that to 1.7. Okay, so that's our question 2. Let's look at something slightly different. So here we've got volume 0.6, density 2.5, and we want the mass. So looking at what we've got, so we've been given a volume, we've been given a density, and we want to know the mass. So let's go to our equation. What do we have? The third one down. We've got mass, we've got density, and we've got volume. So mass is calculated by multiplying density and volume. It's really good news because we're trying to calculate mass. So all we're going to need to do is stick in our numbers. So we've got volume of 0.6, density is 2.5. So we can just multiply those together. That's what the equation tells us. And we get 1.5 kilograms. Okay. So again, looking at the same thing. So we've got a force of 20,000 newtons, acts on an area of 0.10 meters squared. What pressure does that cause? So again, what have we got in the question? We've got force, we've got area, and we've got pressure. So, aha, here we go. Second one down, we've got force, pressure, and area. So to get force, we multiply pressure and area. So there's our equation. What do we want to calculate? We want to know what pressure is. So what I'm going to do is I'm going to divide both sides by A. That gets the P, or the pressure, by itself. Now we can plug our 20,000 in for force. We can plug in our 0.1 for area, and we get 200,000 pascals. How did I know that this was the unit here? Well, it's because if you look in your equation table, it tells you it's measured in PA, which is short for pascals, named after a famous physicist. Using the logic earlier, we could equally have said pressure is measured in newtons per meter squared. And that's actually what a pascal stands for. So either of those would be fine. Okay, so moving on. A force of 20 newtons acts on a mass of 200 grams. What acceleration does that cause? So again, what have we got? We've got force, we've got mass, we've got acceleration. Oh, look, we've got an equation that links those three things. That's down here. The thing I would draw your attention to is this, because this is going to be important in our second. Our mass has to be in kilograms. Back. So, here's our equation. We want to calculate acceleration. So we're going to need to get acceleration by itself. So we divide by mass. That gives us acceleration is force divided by mass. Okay, so now we can start our process. So we're going to go, okay, so the force is 20 newtons, great. Mass is 200 grams. Okay, so that's why I was highlighting in the equation that it needed to be in kilograms. So we're going to need to make a conversion here. So what piece of information do we need? Well, we need the fact that 1 kilogram is 1,000 grams. So if we want 200 grams, we get that by dividing, I don't know why there's a K in there. We get that by dividing both sides by 5, because you can see the right-hand side becomes 200 grams. This becomes 0.2 kilograms. So that's what we can pop in here. So we put the 0.2 in for mass, and we get an acceleration of 100 meters per second squared. Incidentally, another way to convert from mass in grams to kilograms is to divide by 1,000, which is what we looked at last week in lesson. Okay, there we go. So that's our acceleration. And we have to remember to make a unit conversion. So be paying attention for that from now on. An object travels a distance of 2 kilometers in a time of 10 seconds. What is its average speed? Well, what have we been given? We've got distance, we've got time, and we've got average speed. So, oh look, we've got an equation linking those things. Thing I would draw your attention to, distance has to be in meters. So if we starting off the same way, distance is average speed times time. Divides both sides by time, gets v by itself. We get v equals distance over time. Plugging our numbers in, our times in seconds, beautiful, we can put that straight in. We've got 2 kilometers in there. So again, we're going to need to make a conversion. So the information that I'm using here is that 1 kilometer is 1,000 meters. So 2 kilometers, therefore, is 2,000 meters. So that's what we can stick into our equation. And then we can calculate it that the average speed has been 200 meters per second. Okay. Finishing off, thing to ask yourself is, did you understand each step that's done and why each step was done? If you don't, this is the time to ask someone who does understand. So make sure for each of the calculations we've been through so far, do we know why we've done each of the steps? And if you do, that's great, because that's what we're working towards with these equations.